So one of our patterns of these sections is to now determine the equation of a hyperbola based on particular information that's given to you. So it's kind of the same approach as what we did with the ellipse, but we want to make sure we can catch everything. So again, my preferred way of approaching these problems is to have a nice XY axis right by me so that I can plot what I see and then count to determine the important parts of the equation. So right now they're telling us the vertices of the hyperbola are at the points -4, 3 and 12, 3. So I'll plot those right away. -4, 3, 1, 2, 3. And usually you'll see me labeling them. Now 12, 3, I think my axis only goes out to 10. So let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be your job, just add on a couple notches to get that 12, 10, 11, 12. And again, it's at +3. So you kind of have to eye it. If it helps, you can draw more of your coordinate system, or maybe you already have graph paper that helps you. So whatever works for you. I should be a little more neater though. I'll kind of attach more onto my grid just in case I need it. It's really good to help with visualizing on that part. Okay, so that's another vertice. So right away, just by plotting the vertices, I can see that they're on a midline. I'll draw this for now. They're on a midline that is parallel to the x-axis. So it's a horizontal axis. So what we're looking at is that we have a horizontal hyperbola. So kind of little note to yourself. Horizontal hyperbola. Great. That means they look something like this, opening up to the left, opening up to the right with the branches. So if you do have your vertices, the next thing you could be interested in is just finding the midway point to kind of see where your center would be. So you could count the distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if you cut 16 in half, that's 8. So you can kind of figure out where the midline is. So 1, 2, 3, 4, 5, 6, 7, 8. I have my center. So that gives me a heads up. I have 8 units to the left and 8 units to the right. And guess what that tells you? That tells you your a square term. But let's kind of write down the center just in case. I know I found it, but I want to name the coordinates. So if we want to name that from counting from the origin, that's 1, 2, 3, 4, 3. Okay. So you could kind of say, well, if I know it's a horizontal hyperbola, I know that my x term comes first with the a square. No, it's horizontal, not vertical. We'll go from there. So x minus h squared over a squared minus y minus k squared over b squared. So x minus h squared over a squared, y minus k squared over b squared equals 1. Do not forget that. That's important. So now you could kind of say, okay, well, let's fill in h and k. That's going to be x minus 4. And y minus 3. Notice x always comes before y when you're naming this. We got that part of the equation down. We also talked a little bit about the distance. The distance from the center to the vertex gives you the a. So we figured out that a was 8, which right away gives us a squared equals 64. So let's erase the a squared or write the 64 in. So now I'm kind of stuck. I kind of look at things and say, well, they didn't give me what the box would look like. So I don't quite have b squared quite yet. I look at any other information they're giving me, and I see that they're referring to the foci. So that's one of the focus points at the point -6,3. So I'm going to draw that in. So -6,3, 1, 2, 3, 4, 5, 6, -6,3. And I'll label that with F for focus or foci. That is good news, by the way, because when they give you what the focus point is, or one of the foci, they're actually referring to the distance from the center to the focus point, and that's going to help us out with C. Now, not to be confused with C for center. I should be careful with that. So with the hyperbola, the C is the distance from the center to the focus point. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, look at that. Nice little 10. So this is good news, because if you have A and you have C, you actually have formula C equals square root of A squared plus B squared. And we could actually find the B squared finally. So let's replace the C with the 10. And we have the square root. Let me get the A square in there. So that's 64. And we have plus B squared, which is what we need to find. So we're going to have to use our experience in solving radical equations. Right, Leica? What do you think we should do first? To undo the square root, we're going to square both sides. That's going to leave us with 100, that's 10 squared. The radical will disappear, 64 plus B squared. Now, if we subtract 64 from each side, 100 minus 64, we actually end up getting, what is that, 36? Lucky. That makes me happy. You know why that made me happy is because I get a B squared equals 36. And if I have my B squared, I could tell who B is. So B is equal to 6. Remember, we're kind of using the B squared to help us. We can now replace the B squared with a 36. And we actually have our equation of the hyperbola. So the last thing we'd want to do, well, second to last thing, it might be beneficial just to draw this now. So let's use our B. And remember, our B counts upwards from the center. So that's 6 units up. 1, 2, 3, 4, 5, 6. And 6 units down. 1, 2, 3, 4, 5, 6. That is going to allow us to draw our box. So let's do that. Remember, it's the box that is made with the vertices and these other 2 points that we just drew. So you see me drawing dashed lines, or a dashed box, I should say. There we go. Now that we have our box, the next thing we can do is just draw our asymptotes. So you kind of see that all I'm doing is going from the center through each corner of the box. It's kind of nice. You can make a really pretty graph freehand. Feel free to use a straight edge. I'm a little shaky at the end of this lecture right here. But we do have the equation. We have almost the graph of the hyperbola. We just have to draw the branches. And remember, we're drawing the branches to open up to the left and to the right because we have ourselves a horizontal hyperbola. So the branches always deal with the vertices. So just remember, when you're making the branches, you're hugging the asymptotes. There we go. So that's the graph. We're good to go there. The last thing they wanted us to practice were the asymptote equations. So what I will go through is I'll walk through the idea of the y minus k equals plus or minus the slope, x minus h. I noticed that it's always related to what the equation of the hyperbola looks like. I didn't quite use the a over b or b over a because I'm really just going to use my graph to help me determine who's the rise and the run, but feel free. So if you're kind of looking at what's associated with the y in this equation, here we go, try to center it for us. We should have y minus 3 equals, we have the plus or minus. I'll deal with the slope in a second. The x term is x minus 4. So all you're doing is kind of using the center to reshift those lines. The other thing is just understanding your slope triangle. So remember, you can go anywhere you'd like. I'm just kind of using a slope triangle going from my center rise. I'll notice that my rise is 6 and my run is 8. So 6 over 8. And we're almost there. That is correct technically, but all we want to do is probably reduce if it's possible, makes our lives a little easier. So 6 over 8 is actually 3 over 4. So now we have the asymptote equations in point slope form. And that's as good as you need to take it. If you want to solve for y, you can, but don't make too much work for yourself, because then what if you make a minor mistake? Things happen. So just make sure we followed all the directions of the problem. I hope this helps. Like I said, drawing this really helps us see the important parts of the hyperbola. Feel free to refer to the formula sheets if you need to, but sometimes like the less you crowd in your head, the better it will be. So I do hope this helps. I will see you in the next section.